To introduce to you Nadieh. Please give her a warm welcome.
Thank you. Thank you. Hi, everyone. So, I don't have much trouble saying no to something that I don't think I'll enjoy, at least I think I am. However, saying no to something that seems awesome, I'm exceptionally bad at. And that's why I've had a to-do list beside my laptop since December of 2014, when I first discovered my passion for the visualization of data. I do cross things off every now and then, but new items appear just as fast. But to be honest, I don't mind this permanent lack of having enough free time left to actually get bored. My personal projects have given me opportunities that I didn't even know I was looking for. And I also think they played a really big role in me being able to pursue a freelance career now almost 3 years later. And my favorite personal project is the one I want to share with you today. And it's a year-long collaboration that I did with Shirley, who is, like me, a freelancing data visualization designer, although she's based in San Francisco and I'm from Amsterdam. So to set the scene, a bit of background. Shirley and me first met in a data visualization Slack channel, and then met in real life a few months later at OpenVisConf, where we both had the honor to speak, and we really hit it off during those 3 days of conference. And a few weeks later, I was publishing tutorials about the different aspects of my talk, and Shirley really jumped on them and started asking me all kinds of questions. And somewhere during those talks, we started lamenting the fact that we hadn't created as many more advanced data visualization projects in the previous years we wanted to. It was mostly other kinds of projects. So suddenly Shirley asks me out of the blue, do you want to collaborate and create stuff? And I think it took me mere seconds to reply with an all capital yes. And that's how Data Sketches was born. So in the following week, we figured out that we both liked the idea where we would create a visualization each month around a specific topic, to see how two people would create two visualizations, starting from the same seed, but then diverging into different paths based on our own interests and history. Well, besides sharing the end result, we also wanted to write about the creation process. And we split this up into the 3 pillars that we find most important: data, sketching, and coding. And initially we thought we could pull data sketches off with about 5 to 6 hours a week, but as usual, real life doesn't care about plans, especially coding plans. So since starting in July of 2016, we've clocked many hours into creating our visualizations each month. And during this talk, I'd like to take you through some of the lessons that I've learned, the challenges faced, and the insights that I gathered along the way. So to start with the most fundamental aspect of data visualization, the data itself. And a question that we often get is, how did you find your data? But it's usually not the data that leads us. It's the topic that provides a spark of an idea, an insight that we might want to reveal, and how to visualize that. And only after we have that more concrete angle do we investigate if we can find some appropriate data. For example, during November, our topic was books, pretty broad, but I really wanted to focus on fantasy books, or more specifically, the themes and titles of fantasy books. And after I have my angle, I do nothing more special than just Google the web using that idea combined with the words data or dataset. And this has led me to Google spreadsheets containing thousands of rows of Olympic medal winners, or GitHub repos with wonderfully unique datasets, such as one about the words spoken in the Lord of the Rings movies, or a dataset of 3,000 people, a family tree pertaining to royalty that went back more than a millennia. And I've also learned that website design says nothing about the quality of the data that it shares. So there are also websites that contain structured information, but not in some ready-to-download format. Instead, I have to scrape the logical layout of the website and put the information that it contains into a file myself with the help of some code. IMDb has an advanced search, and it returns a list of movies. And each of these movies is contained within the same elements of divs and other stylings. So I can therefore download the HTML structure and then use a script to search for all of the stylings that follow a certain pattern. So all of the movie titles could be contained within the div class title. Or on Amazon, where I could find a list of the top 100 best-selling fantasy authors that I could use. Well, there are also APIs from which you can request information. But I have to admit, I don't often use these because they can be quite of a hassle to set up. But nevertheless, sometimes the wealth of information is just too good to ignore. So with the author names that I scraped from Amazon, I then used the Goodreads API to request the top 10 most rated books of each author, gathering information about the number of ratings, the average rating, and of course the title of each book. Another good strategy can be to just ask others for advice. And during April, our topic was community, and I wanted to do something about Earth, something that would sort of fit the World Wildlife Fund in a way. But I couldn't get my angle any more concrete than that. So I asked Twitter for advice. And I got a dozen or so interesting links that I started browsing, which led me to new links, and so on, until I finally came across this page. And it shows the amount of greenness that is measured from space on a specific day in June. And when I saw this, I knew I'd found my hook. I wanted to visualize the same data, animate it smoothly throughout the year, and try my own spin on the visual styling. So here is the end result that turned into. And although it proved technically complex, it was a lot of data. The visual itself is very minimalistic. Just a title and a simple legend are all that is needed for most, I think, to understand what they're looking at. And finally, you can also create a dataset completely manually, no code required. For our Nostalgia Month, I decided to dive into Dragon Ball Z. And I could find these lists on the Dragon Ball Wikia page that contained all of the fights that happened during the anime. So I just copy and pasted all of these lists into Excel and then split them apart into the characters and other information. And it took me about 2 hours to get this list of 200 fights ready, which I think is still less time than if I tried to write a script that would handle all of the nuances of the text in these lists. Or when I actually spent 2 hours trying to find a proper data set on the characteristics of butterflies and have to resign myself that the best option seems to be contained within a website called Gardens with Wings. And yeah, so again, I thought that trying to scrape this semi-structured website would take more time than a manual approach. So I just clicked through all of the options and copy-pasted the information that I wanted into a final set of 87 different butterfly species. So what I hope to have shown you with all of these examples is that there's not just one specific way to find data. It's not just hardcore data analysts that have these magical skills. It can be found in so many different ways, from Googling and finding the straightforward CSV or Excel file, to scraping a website, or even creating it manually. But be aware that you almost always have to do some final data adjustments to make it ready to put into the visual form that you have in mind. So to dive a bit into what those kinds of adjustments can be, for August, the obvious theme was the Olympics, especially since Shirley and me are both big fans. And I ended up visualizing all 5,000 gold medal winners since the very first games in 1896. And each of these rings represents a group of similar sports, like water sports or ball sports. And then each slice or feather within a circle represents one sport, like athletics. And we have then the first edition over here, going outward to 2016. On the reddish background, we have the female events, and on the blue background, we have the male events. And finally, each medal is given the color of the continent in which the country lies that won. So blue is Europe, red is Americas, black is Africa, and so on. And we can see here, for example, that the very first editions didn't actually have any events for women in athletics. Well, I found the data for this piece from an article written by The Guardian for the 2012 Games in London. And after I sort of had a rough shape of the visual on my screen, I noticed that some very obvious medals were missing from 2012, like hockey. So suddenly my confidence in this data set dropped drastically, and I therefore needed to get an overall sense of the accuracy. But I did not want to have to check all the 5,000 medals manually, so I found a proxy instead. On Wikipedia, I could find the number of events that occurred during each edition, which I then compared to the number of gold medals in my dataset. And if there was a discrepancy, I dug deeper to figure out where and why. And that's how I found out that for some of the years, the horses were also in the dataset, which makes for an interesting read to suddenly see Princess and Sissy and Lady Mirka as women winning gold in the Olympics. Well, eventually I managed to figure out all the discrepancies and made adjustments to my data to get it to the point where I trusted it again. So my lesson here was that even if a data source comes from a respectable source like The Guardian, you should always get a sense of accuracy and completeness. Missing data can be harder to find than wrong data. And you don't have to check every value, but think about taking sums and counts and averages and comparing these to plain common sense, or even better, a different data source. And staying with the Olympics, I also want to dive a bit into data preparation and how that can be connected to creating more exotic or unique visuals. So the standard bar and line chart are so common that you can create them with any tool that lets you do data viz. You just supply the data and the tool or program does the visual heavy lifting for you. And the more you start to deviate from these standard charts, the more that you'll have to supply other aspects of the visual as well, such as where on the screen should the data be placed. It can take some time to figure out and calculate these things, but it can get you some wonderful results. So in essence, the form of the visual feathers is nothing more than a whole lot of rotated and curved bar charts, stacked bar charts. And the structure of every feather is very similar. They all follow the same concept, but they also depend on each other. And at first I was trying to sort of calculate the rotations of all of these feathers in JavaScript, but after having written like 30 lines of code and still not achieving something that I knew I could do in 2 lines in R, which is my favorite data prep and analysis tool, I just pulled all of these preparations into R as well. Even if they were visual variables, by which I mean that they have nothing to do with the data, only with how it's laid out on the screen. So I calculated the initial rotation that each of these circles needed to have eventually have the center at the bottom, and the rotation that each of these slices would need to have based on their predecessor. The only placement variable that I kept calculating in JavaScript was the year scale from the center outward, so that I can then shrink and expand the circle based on the screen sizes. But even each metal's offset from the center was something that I calculated beforehand. And adding these visual variables to your data is not a bad thing. It's perfectly fine, and it can be very useful for fixed data sets. Sometimes it's just easier to calculate these variables in another tool than the tool that you're using to eventually visualize the data with, such as JavaScript or Tableau. And for visuals that eventually live in the browser, it can also save you a lot of browser calculations, making it easier to load or faster. And personally, I find that it makes my JavaScript a lot more readable, but this probably has to do with my JavaScript skills, though. So, since starting, Shirley and me have filled many pages of our notebooks with sketches, because they help us think and lay out ideas beforehand. And my sketches are often very simple, only focusing on the main abstract shape that I want to fit my data into. Colors and layout and details. These are things I only vaguely think about but don't act on until I have the data on my screen. There's just no use to spend any time on these things until I've figured out that the visual actually works once I've morphed it into the main shape. For the Olympic feathers, for example, I was inspired by the shape of a peacock feather, which places sort of more emphasis on the later editions. But I made a sketch that looked like that, but I had no idea how that would look once I finally placed 5,000 metals together. So I had to see if the general shape would work before moving on with my design. And I started laying out these feathers, and it took a few steps, but eventually I got to a point where I saw that thankfully there did seem to be something interesting in this idea. However, sometimes there's no use to start sketching. However, I will say that it's very rare, but networks are an exception for me. And for our October month, I decided to dive into royalty. So I've always been intrigued by how intermarried the royals really are. Are they all cousins twice removed? Well, luckily, I found a genealogy data set containing a gigantic family tree of the European royal houses. It was from 1992, so I had to spend a fun evening on Wikipedia adding 1 or 2 more generations in the main line of succession. But yeah. And here is the end result. So we have these 3,000 people, and the current royal leaders are the bigger circles, and everybody is connected to their parents, their partner, and their children. It never really wants to work very fast when I'm in my presentation mode. But you can hover over anybody and see how far their 6 degrees of separation reaches into the web. And you can also click on any 2 people to see what the shortest path is between them in terms of relatives. But when I started out with this visualization, I had no idea what was in the data. So I just placed it on the screen using the most basic network settings, and then this happened, an explosion of points and lines going out of my screen. Well, let's rein in that gravity a bit then. So now I was left with a useless hairball. Well, maybe I could color them by year of birth. Nope, not helping. But in the browser, I don't have to abide by nature's laws, so I can have gravity depend on a variable. So I pulled the web apart by year of birth. That was better, but it was still a rather uninsightful bundle. And at this point, I'd already invested several hours into playing with the network settings, trying different kinds of connections, adjusting my data, and I was really ready to just give up and try a different angle, like how much are the royals spending these days? But I gave it one last shot. And that's when I decided to focus on the current royal leaders. So I placed these in a line, and then I let the vertical gravity depend on which of these leaders you were most closely related to. And that's when I finally saw it. Insights. For example, that the Queen of Denmark here is actually very central to the web, or that the Prince of Monaco line over here separated from everybody else almost 200 years ago. And it was only around this point that I really started worrying about the other design aspects. And networks always remind me of constellations, and with my astronomy background, I have a bias for all things space, so I turned it into a starry night. And I could have never designed this visualization beforehand in Illustrator. I had to go hand in hand with the actual data and apply my design choices to all of the data simultaneously to see if the results were both insightful and engaging. But getting back to actual sketching, during September I made my most personal visualization ever. Our topic was travel, and I took the opportunity to visualize all of the vacations I've ever been on. So with the help of my parents and browsing through all of my analog childhood photos and my travel journals, I created a list of all of my vacations and all kinds of information. And I wanted to keep this month very minimalistic. Just a row for every year that I've been alive, and then colored blocks on the periods where I was on vacation. And then these blocks would be decorated to give an idea of what kind of vacation it was, where did I go to, how much I enjoyed it, who I was with. So I drew this sketch around that idea. But when I looked at this sketch, I suddenly noticed a big error that my mind was glossing over. Namely, that I'm only on vacation for a max of 4 to 5 weeks a year, which isn't even 10%. I mean, in general, it's not bad, but if I were to put that data into this sort of design idea on my browser, it would be mostly empty, which wasn't what I had in mind. So I made a new sketch in which I did something rather unusual. I decided to squish any month in which I had not been on vacation. That would make it pretty difficult to compare exact months across the years, but that wasn't my main goal anyway. I wanted to visualize trends in my vacations, from mostly sun-driven in early childhood to culture in my teens to nature these days. And by sketching it out first, it reminded me of I saw that my initial idea wasn't going to work, and it guided me towards this new approach. And here is the final visual of all 30 years of my vacations. But to be honest, my favorite part of this month was actually just reminiscing with my parents over old photos and memories. And another thing, there's another example I have, and the Olympic feathers comes back quite often in this. So I saw this image of a peacock feather, and I started drawing some of these feather shapes. And initially I thought that all of these shapes, they would represent one sport and they would be completely filled with colors. But again, while sketching, I suddenly realized, wait, the events change during every game, so how would that work? And then the next day, I explained my rough idea to a friend, and again, sketching out parts of it, and again, while sketching, I found that my mind was glossing over some logical errors. So only by sketching out the shapes several times, figuring out my thinking errors, and iterating again, did I get to a final shape that at least seemed to make sense on paper. So instead of going straight from your data or an idea in your head to a computer, just make a simple sketch on paper first. And there are ideal ways to quickly catch thinking errors. And you don't have to be some sort of artist to create data-viz designs. They're mostly circles and squares and simple curves anyway. If you cannot make it work logically on paper, it is not going to work on a computer with the actual data. And something else I investigate while sketching is how to add extra details. So how to create more context around the information that I want to convey. So although the Olympic feathers is already very high in the amount of data, I couldn't resist adding information about the world and Olympic records, because every athlete there tries to break at least the Olympic, if not the world record. So I added a small white dot on each medal that resulted in a record, such as here for Usain Bolt's 200-meter dash in Beijing. And a way for me to think about adding extra details is to think about the visual channels that are still free after I have my main chart standing. Let me explain that a bit more with another example. So for the past 17 years, during exactly 1 week in the year, more than half of the Netherlands listens to the same radio station. I know we're a small country, but that's still rather odd. Nevertheless, this happens during the final week of a year, when the 2,000 best songs ever are aired, counting down to the new year. And it is quite a thing for a Dutch person. So I asked Shirley if our topic for December could be music, so I could tackle these 2,000 songs. And I wanted to visualize which decade was most popular in terms of song release year. So here we have the base visual, where each circle is a song, and they are clustered to sit at the year of release, from the 60s to today. The bigger the size, the higher the position in the top 2,000, and the darker the color, the higher the position it ever reached in the weekly top 40s. But there is so much more interesting information that can supply context to this visual, such as song name or artist name, and to be honest, I also felt like the current visual was just a bit too boring. So I thought about, okay, so what visual channels do I still have available? Well, I can still give the circles a stroke, or I can add an extra mark on top, or I can use textual annotations. So here's a new sketch that sort of incorporated those ideas of adding extra details. And because in 2016, David Bowie and Prince sadly died, I decided I wanted to mark all of their songs and sort of mention how this had changed with respect to the list of 2015. But I could also use the rankings of the songs in different ways, to highlight the most popular band, or where to find the most popular song from 2016, which one was the highest riser or newcomer, and to single out that Pokemon song. Or even just to highlight the top 10 songs more clearly by adding an extra mark on top. And by adding these extra bits of information, I felt that the visual could be more fully understood, enjoyed, and it made for a visually more interesting piece as well. So even if your main chart is making the information insightful to your audience, also try to think about adding extra details. To use remaining visual channels to add new variables that can supply more context and that give the truly interested reader even more ways to dive into and understand the information. And as expected, most of our hours are actually spent on getting the data on the screen. And here are some of my perhaps less obvious coding lessons. So for our very first month, the topic was movies. And for me, it was pretty clear that I wanted to do something with The Lord of the Rings, which is my favorite trilogy. And I thought with the popularity of the movies that there would be loads of data to be found online, which didn't turn out to be true at all. But I found one really interesting data set nevertheless. In someone's GitHub repo, there was a dataset that contained the number of words spoken by each character in each scene of all 3 extended editions of The Lord of the Rings. I mean, how amazing is that? I knew I had to visualize that some way. And I decided to focus on how many words has each member of the fellowship spoken at each location in the movies. But as you may be able to see on the screenshot on the left, there's no location information there. So, with the help of online scripts and my own memory of having seen the movies way too often, I manually added the locations to each of the lines. I mean, a little dedication can go a long way. And I made a sketch, and I quickly converged to something where the members of the fellowship would be in the center, and the locations spread around in a circle, and then they would be connected by these strings, where the width of the string would represent the number of words spoken by that character at that location. Well, sadly, this chart I didn't know that it existed in any of the tools that could do data viz. But it reminded me of a chart that did exist. It's called a chord diagram. So instead, I wanted to see if I could transform the chord diagram into my sketch. And here is the basic stripped of all text chord diagram. And the most fundamental thing to me is if I could see if I could make these inner chords, or strings in my case, move towards the center, which didn't take that much time as I had anticipated, which is very rare for me in coding. But getting rid of the excess space, and now it was ready to handle the actual Lord of the Rings data and some more appropriate colors. Well, we have 9 members of the fellowship, so making sure that the inner parts end up at the right location. But this was just way too squished. So I just pulled the 2 halves apart, which was mathematically a fun challenge for these inner strings. But the strings were still looking very odd, especially in the top and bottom. So I finally dove into learning how to write my own SVG paths to make these strings look more natural, which was the thing in the project that took most time. But that's how I ended up with this new chart that sort of mutated from the chord diagram. And because of all these strings, it could really benefit from some interactivity to supply context and focus. So if you hover over a location, you see the people that spoke there, and if you hover over a character, you see all of the strings and locations that are not connected to him are hidden. I update the word count so that you can see exactly how many words Gandalf spoke at the Shire, and a small note at the bottom that gives an insight that I'd found for these characters from this data to make it easier for people to understand the types of insights that they might be able to find. My favorite one, by the way, is Boromir, who is really only alive during 1 movie. He still manages to speak more than Legolas does in 3. So many people have done amazing things that they share online. So even if you are thinking you're creating something new, it doesn't always have to mean you need to start from scratch. Pick the thing that lies closest to your design and start adjusting that. Remix what's out there already. And there is nothing actually that I learned more about during that year than creating my own SVG paths and how much more possibilities they can give you in terms of how to shape your visual. From simple curves instead of straight lines in my royalty network, to sweeping arcs in my visualization about fantasy books, to the feather shapes that I really did create at the start, but that never made the final version, and the string shapes from the Lord of the Rings visual from just now. And another project that is heavily based around custom SVG paths has to do with my nostalgia month. And I decided to dive back into something that I was crazy about during my teens, Dragon Ball Z. So for those that sadly don't know it, Dragon Ball Z is an anime about fighting. So I thought it would be fitting if I could create a visualization about all of the fights that happened during this anime, and to sort of visualize who fought whom, what state were they in, Super Saiyan, and what was there anything special about the fight. And here is the base visual. Each cluster of circles is 1 fight, and it's ranked from the first fight to the last one. And then from left to right are the different sagas, which is sort of like story arcs or seasons. And then within a fight, each circle represents 1 character. And to more easily follow a character from fight to fight, I wanted to connect all of their fights by a line. So I started out with a simple path zigzagging back and forth. And I've done this with a collection of so-called quadratic Bezier curves. I probably pronounced that wrong. Which give you the option to pull on these line sections by using these anchor points. To make the visual a bit more interesting, I decided to pull harder if the distance between 2 consecutive fights was farther apart. And then I got some great advice to use the side of a fight to denote good versus bad guys. So swooshing on the left-hand side means good guy, on the other side means bad guy. Which means that for this character, Vegeta, he started out as a bad guy, moved around a bit, before mostly becoming one of the good guys. Well, introducing the other characters, and this had something interesting going on, and I was seeing insights and patterns that I'd never realized before, but I just wasn't liking the single thickness lines. They just didn't convey the dynamic nature of the fights. So instead, I wanted to construct a shape that I would fill, which would mimic a line of varying thickness. And therefore, what I typically do, I draw out my desired end state on paper, and I try to deconstruct it in terms of its mathematical, or in this case, SVG path elements, which here sort of resulted in flipping the path back up again with different amounts of swoosh, as I started calling them. And by implementing this small change, I felt that the lines connecting these characters were much more visually interesting and fit the data or the topic better. So even though I was talking about these SVG paths here, because so many of my visualizations are built up of SVGs, in general the lesson here is that really try to embrace the advanced functionalities of a tool if you want to go beyond the standard examples. I was using D3.js for 2 or 3 years to create most of my visualizations before I finally took the time to learn how these SVGs and paths and things are created. And it opened up a whole world for me in terms of possibilities and creativity, so I actually wish I'd done that sooner. Another thing we had a lot of fun to play around with last year was math. And for example, here is my addition to our collaboration month with Google News Lab. And being a non-native English speaker, I wanted to focus on translations. So what do other languages want to have translated into English using Google Translate? From the most translated word of 10 chosen languages to the top 10 for each of these languages, and finally, similarities between these languages. And for this top visual, I wanted to string together these most translated words by a swirling path that would contain the 100 most translated words overall. And preferably, I wanted something organic looking like this. But for the life of me, I couldn't draw out something that would mathematically create a similarly organic swirl and that would be updatable and responsive to both desktop and mobile sizes. So therefore, I decided to use sort of a beads on a string idea slowly zigzagging down. I typically make some mistakes in my math that reveal themselves once I've coded it out, but eventually I got it working in a layout that, depending on the screen size, would show either 4 beads, 3 beads, or 2 beads. And the last visual on that page also turned out to be a rather fun logic and math error. And in it, each word that 2 languages have in common in their top 10 is represented by a line. But my initial goal was to have all of the visuals build up completely out of words. So I really wanted to have these lines replaced by the words that they represented. But once I had that sort of coded out, I saw that it was a mess. So sadly, I had to compromise on my initial idea and only show these words on the lines going towards the central chosen language. And one of the main points of this thing is that these words should always be placed in the most upright manner possible for readability. But they gave quite some convoluted calculations for the text paths on which they were drawn, which became glaringly obvious once a user clicks on one of these circles to make it move towards the center. Not quite what you expect. And that's where math and logical problem solving came to the rescue. So granted, it took another few pages out of my notebook to figure out a solution, but eventually I came up with something that seemed to work. And what I do is really more of a hack, because if a user now clicks on one of these outside circles, I fade out the words, and then I immediately replace all of the lines with their final states, but reverse engineer it to look like the initial state before slowly transforming into the final state. So my lesson here is, hold tight, learn to love math, and especially geometry if you don't already, because they are often your best friend in finding a solution to these visual problems. And I want to end with one of my favorite lessons. And our topic for February was nature. And I always wanted to do something more along the lines of data over generative art. And I felt that the apparent randomness of nature sometimes can be a perfect match. And it also reminded me of butterflies, how their paths also feel quite random to me. So I wanted to mimic butterfly-like paths on a page, and that their characteristics were sort of determined by the species. So the color of the species would sort of set the color on the screen, species themselves, line shape, and the thickness of the lines would be the wingspan. And then using lots of semi-random number generators, and in inspiration by the works of Jared Tarble and InConversion, did I let my butterflies free across the screen. And this is the only month in which I make no attempt to make the data insightful to my audience. My goal here was just to delight my audience, to keep them mesmerized and hooked as the page fills up with more and more butterfly paths. And creating a sense of delight can be quite a good way to keep people engaged, especially in the more complex data visualizations. And it can be done in quite subtle and diverse ways. So, for example, on a flight back to Amsterdam, I was without Wi-Fi, so limited in my options. And therefore I decided to just create an animated legend of my visualization about fantasy books, just for fun. And other non-essential things that I've added are animated GIFs of the most memorable moments in Dragon Ball Z, or having hovers with the most detailed information that I had for my top 2000 visual for the music nerds that want to investigate, or turning these top 10 songs into tiny vinyls, or adding annotations about silly and weird events that happened during the Olympic Games, such as Henry Pierce having to stop for ducks, but still managing to win gold. And although, getting the data on your screen in such a manner as to make it insightful is key, it's the other things to add, such as animations, annotations, GIFs, weird legends, and more, that can make it truly unique and special, and even more of a delight for your audience to investigate. So take the time to think about these aspects as well. And one final aspect, that may be the most important aspect of doing a collaboration, is that you're not in it alone. So although Shirley and me were creating our visualizations separately, we shared our results throughout the process. From discussing initial ideas, to sharing in the joy of finding some good data, and sending loads of screenshots of sketches and works in progress to ask for feedback. And we started out as two people who sort of knew each other through Slack and had a good time at a conference, but we built up an incredible friendship, and we talk to each other practically daily these days. So if you ever want to embark on an ambitious project, I can definitely advise you to search for a partner, because working together will keep you going more easily. I was always motivated to work another evening on my own month when I saw screenshots of Shirley's progress, but I also didn't want to let Shirley down, so it kept me way more motivated to stay on track. You keep each other accountable in that sense. But it's very useful if at least one of you is responsible, so you don't both slack off. That it's someone that you respect and that you trust, or that you can think you can learn to trust, because that's crucial in giving and receiving feedback. But so one thing to remember though is that no matter how enthusiastic you are about starting or how much fun you're already having, at some point it will get hard and it will require a level of dedication. Try again if you're having a bad day, but at least try again. Because with every new visual or demo or app that you create, you'll learn new skills that you can then use and develop further on your next creation. So that's why, in my opinion, these personal projects are absolutely amazing and definitely worth the time investment. So although I've been taking you through a journey through my lessons and visualizations, Shirley also made one each month with her own angle on the topic. And here's a sneak peek of 3 of my favorites. And the first one is her take on our movie month called Film Flowers, in which she scraped the top summer blockbuster movies from IMDb for every year that she's been born and turned them into flowers. So every visual part of the flower represents some value, from size being the rating, color signifying genres, and the petal shape being the age rating. And then each movie turns into its own unique flower. And I really love the visual or artful appearance of this piece that you can sort of print out, hang on a wall, and still investigate and compare movies across the years. Second one is Hamilton. And although it was published during our Books Month in November, Shirley had been working on this piece that represents every line spoken in the musical for a few months before that. That's how crazy she is about Hamilton. And you should definitely read her write-up of this month to see her level of dedication and data gathering alone. But as you scroll down, Shirley takes you through the lines spoken by the main characters, and you can sort of play around with that and see who sang together. And finally, it focuses on the story arc of one character in particular. And I really enjoy the sense of delight that you get by just scrolling through and interacting with the elements on this page. The final one is her take on the Music Month, in which she contacted the website owner of a huge DDR website, Dance Dance Revolution, and requested the data of all of the moves of all of the songs, which she got. And then she visualized each of these songs by a spiral, time going outward. And I again love this piece due to that it looks quite like a piece of art, but it's still conveying insights. So please check out her other months as well, because they're all fun, unique, and gorgeous takes on our topics. So during the last year, I've learned to find data in the weirdest of places, that it's not blasphemy to pre-calculate visual variables, that sketching helps weed out thinking errors, but that you can also sketch with code. That SVG paths are amazing, and math is too, but we really already knew that, of course. And that surprisingly small things can create a sense of delight for your audience. And we both then set out to be confronted or learn all of these things. We just wanted to have fun, and in that we definitely succeeded. And even though the year is already gone, we actually still have 2 months left. Besides, even though we were having fun, during the final stretch, we noticed that we'd taken on a bit too much on our plate, so we decided to take things a little bit more slowly. So if you want to, you can still join us in our final 2 months of sketching out ideas and coding it up into often fun, weird, and overtly elaborate data visualizations. Thank you very much for your attention. Thank you.
Thank you, Nadieh. I love data visualization, so I was like, I loved the whole talk. We have a few minutes for questions, if you're fine with taking some questions.
Sure.
If any of you has any questions around what she did, what she does besides it, details of what she showed, please raise your hand. You can take a minute to think about your questions because I'm going to ask you a question.
All right.
Yes. So I've got a question about, you mentioned in the beginning you wanted to invest 6 or 7 hours a week for this. How much did you end up investing? Because these things are really elaborate and quite impressive pieces of work.
So the first few, I didn't actually clock my own time, and I knew it was more. But since January, I've been timing myself, and I do seem to end up at more like 80 hours per piece in 2 weeks. Or what I usually have is that once I start, I do 80 hours in 2 weeks, and then I have 2 weeks to sort of get back up again from that experience, and then do it again.
Wow. All right. Any questions from the audience? Anything you want to know? Otherwise, I'm going to ask you another question. I'm always wondering, you mentioned it, what is it with circular charts that, you know, why use a circular chart, and is there a replacement for every circular chart that is actually not circular? I was just wondering about it. I got confused about that.
Yeah, so people do seem to have a preference for circular things. There's actually a book called The Book of Circles that sort of dives into that. But anyway, there are reasons why circular charts are actually good. It can either be to show cyclical events such as seasons, or it can be to show connections in between things. Otherwise, you'd have to lay it out, and then the connection would be very long. What it's not so good for is, for example, line charts that have nothing to do with cycles, because it's quite difficult to compare, is the height of the line from the base here bigger than the height from the line of the base there. So it's more that if you are choosing for a circular chart, make sure that it's a very, that you've thought about it, and don't just do it because it looks fancy, in a way. That you can still see the insights from it.
Awesome. Thank you so much.
Thank you.
There's a question. I'm coming to you.
Hi, nice talk, by the way.
Thank you.
I would like to know about what are the methods of data gathering? Like, which methods do you trust? Like, we are bombarded with a lot of things, like you find plenty of online resources, offline resources. How do you trust, or which one do you trust, and then define your data?
Yeah, it's always difficult with online resources to say how much you trust them. And typically, when it's sort of like a one-off file that I find somewhere, I don't necessarily trust it that much. So you have to do some calculations to figure out, is it complete? Do I have every month of every year that I expect? Are the numbers way higher than what a normal like income would be? But there are websites such as the government websites, or the World Bank website, and all kinds of funding websites that have this data parts of their website, and from which you can expect that should be qualitatively pretty good, because they staff people to actually put that data on there. So it depends on where you found it, like how rigorous you need to be in finding ways to check your data. No.
Great. Any other questions in the room? There's one more question.
Thank you for the talk. When you're sketching out, how do you consider the data? Do you take like the 10 to 20 most obvious, or the most extreme data?
So I typically try to sketch out first just a rough idea of, I have this, at least with data sketches, I have a topic and I think about, oh, what would I do with it? What would I find interesting to visualize? Then I think about what variables would I need to visualize that? And then in an ideal world where I have all those variables, I would sort of do it like this. And then I start looking for the data. If I can find something, sometimes I have to compromise a bit, I can't find all of the data. But then as quickly as possible, I try to shape all of the data into the sort of the rough shape that I had in mind to see if that would work, or if not, everything's like bunched together, I can't see the difference, or they're all sort of the same size, so I can't see anything. So it has, and then I might sketch a bit more to either adjust things or to think about other aspects such as the layout, or how can I put different things together. So it's a very back and forth process, but more for client projects, I have to take whatever they can give me at some point, but for these personal things, all of the data from the start. Because there can be a few data points that can screw up your entire visualization. And it can give you a much better idea if you have 5,000 data points, how it would look if you make everything go between blue and green on these 5,000 data points instead of just 2.
One last question. Anybody has one last question in the room? Yes.
Hi. So just imagine I have all the data in the world, but I'm a non-coder, and I want to be able to use that data and spit out some really easy to read visualizations. Do you recommend any tools or wizards that I can just plonk this data in?
Yes. One thing I would recommend before, though, is having a goal. What do you want to visualize if you have all of the data? But after that, there is, for example, raw graphics. It's an online app, so you put the data there, but it doesn't actually get uploaded anywhere, so it stays on your side. And then it's just a click-drag kind of thing, and you have amazing amount of adjustments and a lot of visualizations that you can pick from. There's Tableau, which can be extremely light on the coding, or maybe even no coding, but the free version uploads your data somewhere, so it might not be suitable for sensitive data, but it's again a click and drag and has a huge community behind it. And in terms, I guess, in raw, there are things like quadragram, which is more to create data stories, so more of like a page with text and visuals in between that are interactive. There's high charts, although I'm not quite sure if they have a non-coding part. But at least raw is my favorite by far, and otherwise Tableau, quadragram are really good.
Fantastic. So I want to thank you again, Nadieh, for coming and talking about data visualization and showing a lot of lovely things. Give a final round of applause to Nadieh for her talk.